All right, let's get to our notes for today on solving literal equations. These notes are for both Algebra 1 and Algebra 1 Honors. Before we start writing things down, let's make sure we have everything we need. So you should have a pencil and a highlighter and probably just have your calculator nearby. I don't know that you'll need it too much. Well, let's get going here. All right, so before we begin, let's talk about our lesson goal today. So our lesson goal today is to be able to, we're going to highlight this, manipulate literal equations for an alternate variable without knowing the values. So basically, we're going to be doing multi-step equations, but we won't have any values. We'll have mostly variables. So we're just kind of changing the way the equation looks in order to solve for a different variable than it's usually set up for. All right, we'll know we understand the skill when we can use our new equation to find the intended solution. So let's see how this works. So we have experience solving a variety of multi-step equations, but now we can apply our skills to literal equations and formulas. So here's some vocab terms. A literal equation, or literal equations, they're equation using two or more variables. So the most common type of that we use are formulas, which is an equation that states a relationship amongst quantities. So let's take a look at these down below. We recognize these formulas right here. Okay. The thing that's important to note is that some of these formulas that we know have the same variables, but they represent different things. I think your notes may say amounts. If you could change amounts to things, that would be great. Because really, here's what we're talking about. Look at the circumference of a circle formula. Here, we know that R stands for radius. But if you look over here at the distance formula, R does not stand for radius, it stands for rate. So we need to know that those R's are different things. Okay. Also, circumference formula, we have a C that means the circumference. Whereas when we're looking for the temperature formula, C stands for degrees Celsius. So we do need to know what our variables stand for when we're working with those formulas. Today, we're not so much going to be having a specific formula where we have to understand all the steps, but we really need to know how to manipulate that for a different variable than it's originally intended for. Let's look at our steps. I'm going to raise up the notes here. All right. So, always, 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 we need to write the original formula. Whatever formula we're starting with, we have to write it down. We're going to be doing our work on lined paper, so this is going to be especially important. Use the algebraic process one step at a time to solve for the variable we want. And this is something different. I do need you to show me the inverse operation steps. We haven't really been doing that much this unit, but we need to do it for literal equations because it will get rather confusing otherwise. And remember, what you do to one side, you must do to the other. And then once you've done that and isolated the variable you want, you can circle your new formula. It won't be an answer like you're used to getting x equals a value. It'll just be a new formula. And then if needed, you can use that new formula to solve a problem with values that are provided. So I have samples showing all of that. So let's take a look. The first one we have here is solve in terms of W, which is the width, in this volume formula. So here we have volume equals length times width times height. These are all being multiplied together. So this is an easy solve. In order to find the W or isolate it, we will go ahead and do the opposite of multiplying and divide each side by length times width. length times height. And if I do that on one side, I have to do it on the other. So then we see that the length cancels and the height cancels, and we're left with just the width, so we were able to isolate it. On this side, we're just going to bring down what we arrived at, volume divided by length times height will give us width. And that's our new equation, new formula if you will, where we're looking for just the W. We haven't put in any values yet, but we've isolated the W on the other side. So that's what it is to solve a literal equation, to solve it for a different variable than we normally look for. Let's look at this slightly more difficult one down here. I'm just going to raise this up a little higher so you can see this. So here it says solve for x. Okay? And let's look at our problem here. We have hx minus kx equals m. Well, we have two x's, which can make it really tricky. So what we're going to do here is we're going to use a strategy called factoring. So I'm going to make a little note. Use factoring. Make it on the side. You should write it too. I'm going to underline that. Use factoring, which is like reverse distributive property. So I'm going to write that down. Which is like reverse distributive property. I'll put prop. Okay, I'm going to make a little box around that because that's super important to note, and I'm going to highlight that. Factoring is like reverse distributive property. Let me show you what I mean by that. So normally we have a value on the outside and we multiply it by each one on the inside and rewrite the problem to end up with something like this. This time we're going to take the values here and we're going to bring them back to the outside of the problem. So the way I would write my next step is x goes on the outside, and if I divide this by x, I get h minus, and if I divide this by x, I get k equals m. Oh, that's not too bad. Now I only have one x. So what I'm going to do now is to get the x isolated, I'm going to divide by this expression in the grouping symbols next to it. So I'm going to go ahead and divide this side by h minus k because it's the whole difference there, not just part of it. And h minus k here. So this whole phrase is going to cancel out, leaving us with the x. So x equals m over h minus k. Since nothing else is going to happen to that, we can leave it by itself at the bottom, and that is our result. I know it's a little tricky, but I think after a few of those you'll really get it. All right, let's take a look at a problem where we're going to maybe apply our literal equation in a different way. This problem says, what is the radius? So that's what we're looking for, the radius of a circle with a circumference of 64 feet. Round to the nearest tenth, and we're going to use 3.14 for pi. So we don't start plugging in our values yet. What we're going to do is we're going to do a literal equation for the variable we want, then we'll plug in our values. So we want circumference of a circle. So that formula is, look above, C equals 2 pi r. But we want it just for r. So we're going to divide each side. Because these are being multiplied, we can just divide by that product, 2 pi. And 2 pi here as well. Those will cancel out, leaving us with r, which is what we want. And this side is circumference divided by 2 pi. So we've gone ahead and done our literal equation, but now we're going to apply it. So I'm just going to draw a little line between my work. I'm going to go ahead and write my new formula over here, C over 2 pi equals r. and then I can just substitute in my values. C is 64. We have 2, and we're going to substitute in for pi 3.14. Oops, 3.14, like that, equals r, because it has to come down each time. And then we'll solve the denominator, so we get 64 over 2 times 3.14 is 6.28 equals r. And now all we have to do is divide these two answers. So 64, we'll do this on our calculator. Make sure it's cleared. We do 64 divided by 6.28, and we get this large value. But remember, it says in this problem that we need to round to the nearest tenth. So we look over what is in the tenths place. It's a 1, and then we look next door and there's a 9. So that means we round the 1 up one place. So it becomes 10.2, and we should label it. It's going to be feet, so I'll put feet. 10.2 feet is our answer here. So that was a way to use our knowledge of literal equations to then apply it to a problem with values and solve directly for what I need. I hope that was clearer and that you understand how to approach literal equations. What I'm going to do now is I'm going to do a separate video showing you how to solve your homework, which looks like this. Oops. All right, let me come back a little bit. There we go. It looks like that. So we're going to go ahead and work on that homework next in the next video, and then you'll know how to start your homework. All right, I'll see you in class.